Welcome to a session on Debroglie Hypothesis and the properties of matter waves. Electromagnetic wave behaves like particle. On the basis of this assumption, one can successfully explain the photoelectric effect, Compton effect, and blackbody radiation, which means that electromagnetic radiation sometimes behaves like waves and sometimes behaves like particles. In case of interference, diffraction, polarization, electromagnetic radiation acts like wave. In case of photoelectric effect, Compton effect, and blackbody radiation, electromagnetic radiation acts like a particle. So, in order to understand the complete behavior of the electromagnetic radiation, we attributed both the natures. Which natures? Wave nature and particle nature. On the similar lines, de Broglie hypothesized that particles like electrons behaves like waves sometimes. These are called as matter waves and also called as de Broglie matter waves, which means that normally you see electron proton as a particle, but de Broglie says that sometimes they behave like waves. This is called as dual nature of matter, and these waves are called as matter waves. If a material particle acts like a wave, then it should exhibit certain wavelength. It should have some wavelength. So he derived an expression for the wavelength of the matter waves. It is purely based on the analogy of radiation. Based on the Planck's theory of radiation, the energy of a photon is given by E is equals to h nu. So h in place of h there only. In place of nu, c by lambda we can write. But according to Einstein mass energy relation, we can write E is equals to mc square. So if you compare equation 1 and equation 2, both are giving the same result, which means both are representing the energy values only. This is the expression for energy. Equation 2 is also expression for the energy. So we can equate equation 1 and 2. So by equating, we will get mc square is equal to hc by lambda. By rearranging this equation, we will get lambda is equal to hc by mc square. Here c cancels out. So what we will get? H by mc. Here mass into velocity will use the momentum. Momentum of whom? Momentum of the photon. This expression is purely derived for electromagnetic radiation. Lambda is equals to h by p by attributing particle nature of the radiation as photon. On this analogy, de Broglie derived an expression for the wavelength for material particles. Simply what he did is he replaced velocity of light c with the velocity of the material particle. So lambda, wavelength of the matter wave, lambda is equal to h Planck's constant divided by m, mass of the material particle, into velocity of the material particle. Why he changed? Because material particles cannot approach the velocity of light normally. So that's why he replaced velocity of light c with the velocity of the material particle. So obviously this expression become h by p. Obviously m into v is called as momentum p. This is called as de Broglie wave equation. We can also derive an expression exclusively for de Broglie wavelength associated with an electron. If a velocity v is given to an electron by accelerating it through a potential difference v, then the work done on the electron is capital V into E, and the work done is converted into kinetic energy of the electron, which means that in order to accelerate the electron, you need to give potential difference. That potential difference is capital V. If you supply some potential difference capital V, then the electron undergoes acceleration. In that process, it attains certain velocity v, small v. So that particular v into E is converted into kinetic energy. So kinetic energy half mv square is equal to EV. EV is work done, that is converted into kinetic energy. So half mv square is equal to EV. By rearranging this equation, we will get v square is equal to 2EV by m. From that, we will get v is equals to square root of 2EV by m. By multiplying m on both sides, we will get mv is equals to square root of 2mev. Here, mv is called as momentum. M into v is called as momentum of the electron. Go back to the previous definition. Lambda is equal to h by mv. This is the expression for any material particle. By taking this expression, let us substitute the m into v value in this equation. So lambda is equal to h by mv. mv we got it as square root of 2m into me into capital V, where h is the Planck's constant, 2 is a constant, numerical constant, and m is the mass of the electron, and E is the charge on the electron, and V is the potential difference. By substituting all these values, we will get lambda is equal to 12.27 divided by square root of V. But we don't know what is V. So this is the expression for the wavelength associated with an electron. So lambda is equal to 12.27 divided by square root of V angstroms. Let us see some applications of Debroglie hypothesis. Wave particle duality is exploited in electron microscopy, where the small wavelengths associated with the electron can be used to view objects much smaller than what it is visible using visible light. Similarly, neutron diffraction uses neutrons with a wavelength of about 0.1 nanometer, the typical spacing of atoms in a solid, to determine the structure of solids. Then let us have a discussion on matter waves. A material particle is pictured as a group of waves which are called as matter waves or de Broglie waves. Simply, what we can understand is a material particle can be pictured as a group of waves. These are called as matter waves or de Broglie waves. Then what are the properties of matter waves? Matter waves are not electromagnetic in nature. They are not electromagnetic. They are different. Matter waves represents the probability of finding a particle in space. Of course, later we will, in later sections we will see it. Matter waves are independent of the charge on the material particle. Yes, material part material particle, irrespective of the charge, can able to produce matter waves. For example, electron. So matter waves can associated with electron, can associate with proton, can associate with neutron. Obviously neutron is a neutral particle which have no charge, so they are charge independent. Matter waves can propagate in vacuum, hence they are not mechanical waves. This is obvious reason from the process. The phase velocity of matter waves can be greater than the speed of light. Of course, later it is corrected by the concept of group velocity of the matter waves. Lighter the particle, greater the de Broglie wavelength. From the expression lambda equal to h by mv, it is very evident. As lambda is equal to h by mv, as m is very small, lambda is very high, because lambda is inversely proportional to mass. The next one is, the faster the particle, the smaller its de Broglie wavelength. Obviously, as lambda equal to h by mv, lambda is inversely proportional to velocity of the particle. So as V is very high, then obviously the wavelength associated with is very small. These are some properties of matter waves.